Hi everybody, my name is Amanda and I'm here with Emma on the LunaSat, and we're going to be going through Module 6, Activity 2, Vector Plot with you. So just a quick summary of this activity. You'll learn how to use the magnetometer to draw vectors showing a magnetic field, and as you learned earlier, the moon has a very different magnetic environment compared to Earth because there is no known global magnetic north on the moon. Similar to this activity, the LunaSat can build vector fields of a unique magnetic environment with the magnetometers scattered on the moon's surface. Each LunaSat functions as a single data point in this situation. And the goal of this activity is for you to learn how to use the magnetometer to measure and visualize magnetic fields. So the materials that you'll need for this module are your LunaSat, your computer with the Arduino IDE installed, an FTDI and the associated cables, a bar magnet, and your magnetometer vector plot template. And just a quick note that some of these were printed before we made some improvements to this module, so they may say activity 3, but they are for this activity. And you also need some tape, pen or pencil, and the activity 6.2 worksheet so you can follow along. And the code that you're going to be needing for this module is the magnetometer vector plot, and that's going to be in GLE 2023 Module Sketches, Module 6. And I'll just go ahead and find that with you guys. We're going to go magnetometer, and we want the vector plot activity. And I do already have it open, so there we go. Yep, so go ahead and upload the code once you have your LunaSat plugged in. And just as in all the other modules, you do want to make sure that you have the right board, port, and processor selected. So we'll just wait for it to upload. And now that it's done uploading, I am going to open the serial monitor. And hold off on doing anything quite yet. We want to make sure everything is set up correctly at this moment. So you want to keep your LunaSat plugged into your computer, keep the LunaSat as far away as possible from any electronics. This includes your computer. And if you have the 10-foot cable in your kit, this is a good time to use it. And this is because the electrical currents in your computer can create magnetic fields, and sometimes computers have magnets in them too. So now we're going to move on to the calibration step. So you still want your bar magnet as far away as possible, and you want to place your LunaSat in the right box of the vector plot. And from now on, keep your vector plot sheet in this same position. That way the calibration is accurate. Okay, so you're going to press enter to calibrate your LunaSat. And you can see that now we are ready to begin the activity. And this just takes into account any external magnetic fields or the Earth's magnetic field that could interfere with the readings for this activity. Now you're going to go ahead and place your magnet on your vector plot template. And you want to place it skinny side down. And we still want to keep all other magnetic items away from your LunaSat at this time. Yeah, so we got it skinny side down in the designated spot, and we have our LunaSat next to it. And you can use some tape if you want to right now to keep your magnet in place. Yep, so Emma's just gonna go ahead and put some tape on there to keep it secure while we do this activity. And now that it's all set up, we are going to go ahead and actually get some data. So like Emma has it there, we want to keep the solar panels facing up. and all of that good stuff. And now we're going to press enter to get our first measurement. So we're going to hit enter to generate our first vector. So you can see that it output a direction and it says left. And then it gives you some more detailed information with the magnitude in the x direction and the y direction, and also the angle that it forms. But for now, let's just pay attention to this direction, which says left, which means that you're going to go mark on your vector plot sheet from the crosshairs, and you're going to mark it left, as Emma is doing right now. And your direction might be different than this, just depending on which way you set up your magnet. Could be flipped. And now we are going to move it to the second location. So you can go ahead and move it to all of the 4 different locations and get the direction for each of those and draw them accordingly on your vector plot sheet. And if you need help determining which direction is which, we have a handy compass on the upper right corner, which has all the directions that you can draw. And on this slide, you can see how you would use the output of the serial monitor to draw your vectors. For example, this one says upper right with 2 centimeters. And for now, you don't have to be super accurate about the magnitude because we're just getting a general sense of the directions with this side. And then once you feel comfortable taking these measurements, you can go ahead and flip over the magnetometer activity to vector plot sheet. And there are more crosshairs that you can try centering your Lunasat on and seeing what directions those output. And you could even try to use the appropriate magnitudes on that and see how accurately you can draw your magnetic field. So those lines that you'll be drawing this whole time are meant to illustrate the strength and direction of the magnetic field at all those different points. And the magnetic field lines in this example diagram are continuous. So you're drawing little pieces of it, like little vectors that make up this magnetic field. So you can go ahead and make all those vectors, and then at the end, you can compare it to this example on this slide and see how close you got. And like I said, your vectors might be flipped depending on how you oriented the magnet on the very first part.